Avogadro's law says that volume over moles is equal to a constant when pressure and temperature are held constant. So this law is very similar to Charles' law. Instead of temperature, I have moles. So let me draw out my cylinder. Moles are the amount of particles. So this time I'm worrying about the amount of particles rather than the temperature. What effect does that have on the volume? And again, this is very helpful to think of in terms of pressure. Pressure is equal to force over area. If I were just to stop and think about this, if I were to increase the number of moles, what would happen to the pressure? Because if pressure is held constant in this case, I need the outside pressure to be equal to the inside pressure in order for the pressure to be held constant, in order for this not to move. If I increase the number of moles, that's going to increase the number of particles, which is going to increase the force. So in order for pressure to be held constant, I'm going to need to increase the area to counteract that increase in force, to make pressure equal still. If I take away some moles, then the force is going to decrease. And in order to combat that decrease in force, the volume is going to have to decrease because I'm going to have fewer molecules in a specific area, so the pressure is going to be decreased. So in order to combat that, the volume is going to have to decrease by an amount to keep the pressure equal. So that's the gist of Avogadro's law. When moles increase, the volume is going to have to increase proportionally to give the molecules more space to keep the pressure the same. And if the moles decrease, then the volume is going to have to decrease to keep the pressure the same. So here's an easy example. Suppose I have, I don't know. Well, let's just think about it this way. If I want to double the volume, what am I going to have to do to the moles to equal the same constant? Well, I have 2V, I'm going to have 2N to equal this constant A. Because no matter what I do to volume or moles, whatever happens to one, the other one has to change in order to still equal this constant A. So if I multiply the top by 2, I'm going to have to multiply the bottom by 2. So if I double the volume, the number of moles is going to need to be doubled in order to keep the pressure constant. Well, let me just make up some real quick example. This is pretty much the same as Charles' law, except I'm dealing with moles instead of temperature. Suppose I have, just keep it easy, 10 liters and 1 mole. And I want to know what happens if pressure, temperature are constant. If I want to know what happens to the volume if I change 1 mole to 5 moles. What happens to the volume? Well, I'm just going to set up like I would any other gas law problem. Or because the constants, I can set both of these equal to the constant, therefore equal to each other. Volume 1 over the amount of moles 1 is equal to the constant. Volume 2 over the number of moles is also equal to the constant. I can set them equal to each other, and therefore I get this, and this is how a lot of times Avogadro's law is written out. But anyways, I want to find the answer to this. So 10 liters, volume 1 mole. And I'm looking for volume 2, 5 moles. So in order to solve this, I just multiply both sides by 5 moles. Moles will cancel and I'll get 50 liters is equal to volume 2.